students, welcome back to our channel Diksha Karnataka. So I hope everybody would have now started preparing for your KCET 2025 examination, right? So while preparing for an examination, while preparing for a competitive exam, one of the most essential component is seeing the previous year papers, solving the previous year papers, right? Because previous year papers gives you an idea about what type of questions are asked, which topics are more important, what type of questions we need to solve to ace the exam, right? So yes, for that reason today we are here with KCET 2024 chemistry question paper. So we'll be solving in this video first 30 questions, that is from question number 1 to question number 30. So this will be the part 1 of this video. In the next video, that is part 2, we'll be solving from question number 31 to question number 60. Okay, so now what is your task here? You need to read these questions, you need to solve it, and then you need to see whether you are able to solve it correctly or not. Okay, so there will be questions from both 11th and 12th standard, right? So some of the topics you might have studied, some of the topics you might not have studied, and some of the topics you might have forgotten also. So just this is an overview, like just to analyze where is your position now for KCET 2025 examination. So yes, please solve all these questions, and then if you have any doubt you can comment down. Okay, so now let's get started with the first question here. Okay, one more thing, the question paper PDF is available in our WhatsApp channel, and the link of the WhatsApp channel will be there in the description section. So go there, you can download the question paper and solve the paper, and then you can also see the solutions here. Okay, so now let's get started with the first question, that is 0.48 gram of an organic compound on complete combustion produce 0.22 gram of carbon. Okay, in so percentage of carbon in the given organic compound is. Okay, so now let us first try to understand this question is from which chapter. Okay, so when you see combustion and you want to find the percentage of carbon in an organic compound, so this question is from the first chapter, that is some basic concepts of chemistry. Okay, so some basic concepts of chemistry, PU1, right? Now let us try to solve this question. So what is saying, there was one organic compound. Okay, let us assume that there is one organic compound. How much mass of this organic compound was there? 0.48 gram. Now it was on complete combustion, means it reacted with oxygen, so it was undergoing combustion. Okay, and when there was combustion, it produced 0.22 gram of, here I am writing, it was CO2. Okay, so question, it's a small matter, 0.22 gram of carbon dioxide. So what is this amount given? 0.22 gram. Now what is the thing here? You need to find the percentage of, so this organic compound will definitely contain carbon. There's no doubt in that, because organic compounds are made up of carbon, hydrogen and some other elements. Now the question is, if this organic compound is combusted and we are getting 0.22 gram of carbon dioxide, then what is the percentage of carbon in this organic compound? Okay, I hope this question is clear. You have an organic compound, just imagine like this, you have an organic compound, you are allowing this substance to undergo combustion. Once it undergoes combustion, it will produce carbon dioxide, and you know how much amount of carbon dioxide is produced. Now the question is asking, what is the percentage of carbon in the given organic compound? Okay, so now how to approach this question? So here you need to know a very basic thing, that is the amount of carbon in carbon dioxide is equal to the amount of carbon in organic compound. Now why I am saying this? Why? What is the reason? Well, it is very logical thing here. See, whatever carbon dioxide is being produced, you are adding organic compound plus oxygen to get carbon dioxide, right? So whatever carbon dioxide is being produced, that carbon is definitely coming from this organic compound. This oxygen can come from the oxygen that you are adding, but carbon will definitely come only from the organic compound that you have taken. So how much? Because here it is written complete combustion, so that means whatever carbon is present in this organic compound, everything has got converted to carbon dioxide. So now I can say the amount of carbon in carbon dioxide will be equal to the amount of carbon in organic compound. I hope this point is clear to everyone. Okay, now let us see here. Let us first try to find the amount of carbon in carbon dioxide. So we know the amount of carbon dioxide is 0.22 gram. Okay, the total carbon dioxide mass is 0.22 gram. Now I don't know what is the amount of carbon, what is the amount of oxygen in this 0.22 gram, right? So we need to find what is the amount of carbon in this carbon dioxide. Okay, so now we know that in a normal carbon dioxide, okay, so if the carbon dioxide mass is 44 gram, we know molar mass, if you add this is 12 and this is 32, right? 44 gram of carbon dioxide contains 12 gram of carbon, right? Now 1 gram of carbon dioxide will contain 12 by 44 gram of carbon, right? Now we have how much carbon dioxide in the question, that is 0.22. So I can say 0.22 gram of carbon dioxide will contain 12 by 44 into 0.22 gram of carbon. So now if you solve this, we'll get 0.06, right? So 0.06 gram of carbon is present, right? Now the question is not about again carbon. The question has asked you the percentage of carbon. So I can say that the mass of carbon in organic compound is equal to 0.06 gram. Okay, now let us find the percentage. Percentage composition formula is what? Mass of the element by the total mass of the compound into 100. So percentage of carbon will be equal to 0.06 by 0.48 into 100, right? So now if you solve this, we'll get 12.5. So the correct answer for this question will be option number C. I hope this question is clear. Now let us see what are the key highlights or what are the things that you should be able to understand. First thing is this one. We need to analyze this thing. We need to understand this thing. That amount of carbon in carbon dioxide will be equal to the amount of carbon in organic compound. Second thing we need to do is this one. How to correlate this one. In 44 gram there is 12 gram. In 1 gram how much gram? In 0.22 gram how much gram? Once we get this, this formula is the, like this part is the direct application. But to get this, we need to know some basic concepts of chemistry. I hope the first question is done for everyone. Okay, now let us move to the second question here. So we have come now to the organic chemistry. So here it is bromine. Okay. So the question here is, in the given sequence of reactions, identify P, Q, R and S respectively. Okay. So yes, this question is from your haloalkanes, haloarenes and hydrocarbons. So organic chemistry generally comes like mixture of concepts from different topics. So let us first identify P. So what is happening from this compound to this compound? So if you see here, bromine is added on the same side, right? A double bond is broken and 2 bromines are added. So this is addition reaction of alkenes, bromination of alkenes. So you can see addition of bromine, Br2. Okay, so if HBr would have been added, then one carbon would have got H, one carbon would have got Br. But here both the carbons are getting bromine, so that is why we can eliminate these two options, right? Now there is a competition between option A and option D. Now after getting this Br, again you see that HBr is removed, right? So this compound is like this, see, CH2, CH2, Br, Br. I'll write this H in a different color, just a second. Okay. Okay, now see, like this if I write. Okay, so now what is happening here? When you give this Q, we don't know whatever it is, but once we give this, what is happening? One HBr is removed. Okay, if one HBr is removed, one double bond will come. So the product we'll be getting here is CH double bond CH2 and we'll have one Br, right? Now removal, this is called dehydrohallucination. Okay, removal of one hydrogen and one halogen. Dehydrohallucination takes place with alcoholic KOH, right? So here also alcoholic KOH, here also alcoholic KOH. So still we need to see the next one. Now here next one, if you see, so here it is triple bond. Okay, triple bond, this one. Let us make it triple bond. I hope this is visible. Okay. So now what happens is, once you remove one HBr, and if you want to remove another HBr, then we'll get triple bond. So to remove another HBr, we cannot use alcoholic KOH again. We use soda like NaNH2, okay, sodamide. So this is what we have to use. But here you see this is NaOH here, right? That will not work here, but this one will work. So that is why answer is option D, definitely. But let us see the reaction. Now once we get alkyne, it is converted to benzene. So what is this reaction? This is your cyclic polymerization. This reaction you will be studying in class 11. Okay, so that is why I told you it is a mix of all different chapters. So cyclic polymerization takes place under red hot iron tube. Okay, so that is why this one is there at the end. So the correct answer, as we have already discussed, is option number D. Let us see the next question here. The first chlorinated organic insecticide prepared is, okay, so this is again from the chapter halogen, haloalkanes and haloarenes, right? So there is a topic under this chapter. What is the topic? The topic is polyhalogen compounds. Polyhalogen compounds. Okay, so yes, the first chlorinated organic insecticide pesticide is your DDT. Okay, so you can see this is the correct answer here, option number D. Now coming to the next question, question number 4. Which of the following crystals has the unit cell such that A is equal to B is not equal to C and beta is equal to 90 degree, gamma is equal to 120 degree. So now you might be thinking where we have studied. So do not worry, this question has come from the chapter solid state. Okay, but this chapter is your deleted portion. Okay, so now you'll be asking, ma'am, how the question has come in 2024. Yes, there were some questions that came in 2024 from the deleted syllabus, but you need not to worry, because later these questions were not considered, were not evaluated. So we need not worry, this is a question from deleted portion, but I'll be telling you the answers also. So this structure or this lattice parameters are for graphite. Okay, now coming to question number 5. MNO exhibits. Okay, so now this one is your from D and F block chapter. Okay, so now MNO, generally if you think like this, MNO, so it is actually from D and F block, but more it is from solid state also, because solid state concept is also used somewhere here. So if you see Mn has +2 state oxidation, so it is D5 configuration, right? If D5 configuration, it will have magnetic moment. Okay, okay, now but what happens here is the crystal of MNO is like this. We have Mn, okay, and then oxygen, Mn, yes, we have oxygen, then Mn, then oxygen, like this it is a crystal structure is forming. So what happens here is the magnetic moment due to one manganese and the magnetic moment due to another manganese gets cancelled because of this oxygen. Okay, so this mechanism is called as super exchange mechanism. Okay, so now what happens, because of this interfering nature of oxygen in the magnetic moments of manganese, the net magnetic moment comes out to be 0, and as a result of which it is an antiferromagnetic particle, okay, or compound. Now coming to the next question here, that is question number 6. The number of atoms in 4.5 gram of a face-centered cubic crystal with edge length 300 picometer is. Density is given again. So this question is also from your solid chapter, which is the deleted portions. Okay, but I'll tell you how to solve. So there's a general formula for density. Okay, density is equal to Z into M by Na into A cube. Okay, so this is the formula for density. Now what happens, the question is asking for number of atoms. How can we write number of atoms? So number of atoms is equal to given mass by molar mass into Avogadro numbers, right? Given mass by molar mass into Avogadro number. Now what we can do, this is also molar mass here, okay. Now what I can do is, so I can write this expression in terms of molar mass. So if I write, what I'll get, molar mass will be equal to D into Avogadro number, so this is capital A, into A cube by Z into D. Sorry, one second. Okay, I need to find molar mass. So D into Na into A cube by Z. Okay, so there is no into here. Okay, so now what I can do is I'll substitute this formula for molar mass in this formula. Okay, so what I'll get, given mass, okay, by molar mass I'll write these things, that is D into Na into A cube. Okay, then you have Na into Z. Okay, now let us substitute the values here. So Na, that is Avogadro's number, will be cancelled. Given mass is how much? 4.5 gram. Okay, and then you have Z. For face centered, Z is equal to 4, and then density is given how much? 10 gram per centimeter cube. 10 gram per centimeter cube. And then you have A cube. A cube is 300 picometer. So A is 300 into 10 to the power of minus 12 meter. Okay, convert it into centimeter, so I'll get 10 to the power of minus 10. So now you can take 300 into 10 to the power of minus 10 whole cube. Okay, now if you solve this, okay, to get the number of atoms, you will be getting around 6.6 into 10 to the power of 22. So the correct answer for this question will be option number D. Little lengthy calculation, but again you need not worry because this is from deleted portion. Now coming to the 7th question, this is important question from the chapter solutions. Okay, solutions is a very high weightage topic for KCET exam. So if you are preparing, so be very focused, very much give 100% attention to this question. Now vapor pressure of a solution, okay, containing 18 gram of glucose and 178.2 gram of water at 100 degrees Celsius is, okay. So now this question you are having, let us imagine this question like this. We have a container, okay. In this container we have 18 gram of glucose, okay, and we have also 178.2 gram of water. Now what is happening? We have closed this container, okay. So as a result of what will happen, there will be some vapor produced here, right? So the question is asked, what is the vapor pressure of this particular solution? Now whenever we add a non-volatile solute to a solvent, what will happen? The vapor pressure decreases, and this property is called as relative lowering of vapor pressure, right? And we have a formula to calculate the relative lowering of vapor pressure also. So what is that? If you know, P naught minus P by P naught is equal to XB, right? So P naught is what? Pure pressure. P naught is the pure pressure of solvent, okay, and P is the pressure of solution, right? Next we have XB. XB is mole fraction of solute, okay, mole fraction of solute. Now what I am saying is, when you do not, so let us little understand the concept quickly. If you have a pure solvent, it will have some vapor pressure. Now if you add some non-volatile solute to it, then what happens? Some vapor pressure will still be created, but the vapor pressure created now after adding some solute will definitely be less than the vapor pressure when there was only pure solvent. So as a result of what, there will be some decrease in the vapor pressure. So that formula is given by this one. Now the question is asking, you have to calculate this one, P, vapor pressure of the solution. So P naught value is already given to you, 760 torr. We need to find XB, and then we can substitute here to calculate P. Now let us try to find XB. So first let us find number of moles of glucose, that is 18 by 180. So I can say 1 by 10 or 0.1. Now number of moles of glucose, then we have number of moles of water here. So water is your 178.2 by 18. Okay, that is given mass by molar mass. So now let us not solve it, let us keep it in this way. So now if you calculate XB here, okay, so XB will be 0.1 plus 178.2 by 18. Okay, Now let us solve this one. 760 minus P by 760 is equal to 0.1 plus 178.2 by 18. Okay, so now once you solve this, you will be able to calculate that P is equal to 752.4 torr. Okay, mathematics part is your work. Okay, now there is one very simple trick also to find this answer without doing so many calculations. Like there's a trick that you can see the question and tell the answer, right? Are you interested to know that? Let's see here. So when I told you that we'll add a solute, okay, the vapor pressure decreases to some extent. Okay, there is not a very drastic change in the vapor pressure. So now if you see, the pure pressure was 760, so the pressure after adding the solute will be somewhere near to 760, but not too less than 760. Now if you see the first option, 76 and 760 are too different from each other. 752.4 is somewhere near to 760, 7.6 is further less than 760, and 3207, it is that the pressure has increased, right? That is the impossible case. So in that case, if you find B is the only option that looks that can be the more probable answer, and if you do by calculation also, we'll be getting the same answer. Okay, now let us move to the next question here. Question number 8. So again, this question is from solutions chapter. Topic here is deviation, right? So this is your ideal and non-ideal solution. Important topic, you get a lot of questions from here. So a mixture of phenol and aniline, okay, you have taken phenol and aniline, shows a negative deviation from Raoult's law. This is due to the formation of. So negative deviation, when does this happen? When the two substances that you are taking are interacting very strongly, right? Now what happens when you take aniline and phenol? There is a strong hydrogen bonding between these two, as a result of which the interaction increases and the deviation is negative. So that is due to the formation of intermolecular hydrogen bonding. Answer number C. Okay. Now let us go to question number 9. Which one of the following pairs will show positive deviation from Raoult's law? Again, this question is from solutions chapter. Same topic, ideal and non-ideal solutions, right? Okay. Now let us see this one. Okay. Now positive deviation, when does it happen? When the two substances which you are mixing, the interaction is very weak, okay, they are going far away from each other. In that case, we'll get positive deviation. So the interaction should be less in case of positive deviation. Now we had okay, now if you see benzene and methanol, okay, methanol, what do you think? Like if two methanol molecules are there, what type of force of interaction they will have? They will have hydrogen bonding. They will have very strong bonding with them. Now if you add benzene in that, then what will happen? Benzene polar, benzene non-polar, methanol polar, the interaction of methanol decreases, okay. So as a result, what happens? The interaction between these two has decreased and they will show you positive deviation. So the correct answer here is option number B. Now coming to 10th question here. So now we have come to the next chapter, that is electrochemistry. Okay, let us see this question here. How many coulombs are required to oxidize 0.1 mole of water to oxygen? Okay. Now let us understand, this one is again from your like this is, I can say, general electrochemistry. There is 0.1 mole of water. So in water, what is there? O2 minus, right? O2 minus is present in water molecule. Now what will happen if you take 2 O2 minus, okay, and we'll get O2 by releasing 4 electrons. Can I say, see, 1 O2 minus has to release 2 electrons to become O. 2 O2 minus will release 4 electrons to become another O. So this 2 O will combine to give you O2, right? Now what happens? So I can say that so 2 O2 minus I'll get from 2 molecules of water. So I can say that for 2 molecules of water or 2 moles of water, how much charge is required? 4 Faraday. 4 moles of electron, 1 mole of electron is 1 Faraday, 4 moles of electron is 4 Faraday. Now now if I want to calculate for 1 mole of water, it will be 2 Faraday, that is 4 by 2, and then for 0.1 mole of water, it is 0.2 Faraday, right? 0.2 Faraday. Now we need to calculate that in coulombs. Okay, so let us calculate it in coulombs. So if you want to calculate in coulombs, we know that 1 Faraday is equal to 96500 coulombs. So 0.2 Faraday will be equal to will have this much coulombs, right? This into 0.2, so that is this much. So we'll have 1.93 into 10 to the power of 4. Okay, so the correct answer here is option number B. Okay, very simple but easy question, but you need to little bit knowing about this equation, how to use this equation. Okay, coming to the next question here, again this question is from your electrochemistry. So you can see we are going chapter wise in the exam also, right? We started with some basic concepts, then we got solutions, then we got electrochemistry. Okay, so so this is from your Faraday's law. Okay, let us now do this question. You have a current of 3 ampere. Okay, so we'll note down the values here. Current of 3 ampere is passed through a molten calcium salt for 1 hour 47 minutes and 13 seconds. Okay, so we have time of 1 hour 47 minutes and 13 seconds. So if I want to convert this into seconds, like, so 1 hour will be having 3600 seconds. Now we will have 47 minutes. So let us convert this one, 47 minutes into 60 seconds, right? So we'll have 6 sevens are 42, 4, 6 fours are 24, plus 4, 28. We have 2820 seconds, and then we have 13 seconds. So let us add them. So we'll get 6433 seconds. So total time is 6433 seconds. Next we have the molar mass. We need to calculate the mass of calcium deposit. So yes, the formula for this one is your Faraday's second law, direct formula. M is equal to Z into I into T, where Z is equal to molar mass. Okay, Z is equal to molar mass divided by N into 96500 into I into T, right? So now molar mass is due to your 40, then you have 2 into 96500. Current is around 3 ampere and time is 6433 seconds. Okay, so now if you solve this, you will be getting around 4 grams. So the correct answer for this question will be option number D. Okay, now let us move to the next question here. Question number 12 is again from electrochemistry. Okay, the topic here is conductance of electrolytes. Conductance of electrolytes, right? Okay, the value of A in the equation is same for the pair. Now if you see in this equation, the value of A is same for electrolytes when the charge of the cation and the charge of the anion are similar. Okay, like say, like if you see here, this is Na plus, this is Cl minus, so we'll call this as 1 electrolyte. Okay, but if you see here, this is plus 2 and this is minus 1, so we call it as 2 electrolyte. So in this pair there is 1 electrolyte and there is 1 2 electrolyte, so that is why they will not have the same A value. Now coming to option number B. Okay, so this is A, B, C and D. Here if you see, calcium is Ca2 plus, so calcium chloride is 2 type, because this is plus 2, this is minus 1. Now MgSO4, if you see, this is plus 2, this is minus 2, so this is 2 type. So there is 1 and 1 2 type, so again this will not have the same value. NaCl and KBr, so if you see NaCl, that is plus 1, Cl is minus 1, and KBr, this is plus 1 and this is minus 1. So this is also 1 type, this is also 1 type. So when both the electrolytes are of the same type, their A value will be same. So definitely here answer is option number C. Okay, now coming to the next question here, 13. So now we have moved towards your chemical kinetics. Okay, and the topic here is effect of catalyst. Okay, so now let us try this one. For the reaction A to B, okay, so there is a reaction A to B, okay, 50 kilojoule activation energy is 50 kilojoule per mole. Activation energy is 50 kilojoule per mole, okay. So this is your delta H, okay. Now delta H value is given to you minus 20 kilojoule per mole, okay. Now when a catalyst is added, the EA decreases by 10 kilojoule per mole. What is the activation energy for the backward reaction in the presence of catalyst, okay. So now let us see here, we have a reaction like this, okay. A to B, it is minus 20 kilojoule per mole, means the reaction is exothermic, the product's energy will be less than the reactant energy, so I can draw it like this, okay. So this is A and this is B, okay. So now here you can see here, this is the gap is minus like this value is given to you 20 kilojoules, okay. So minus we need not put here because minus shows that it is an exothermic reaction. Now it is showing that activation energy for this reaction is 50 kilojoule per mole, okay. Now the question has been asked you, when you use catalyst, so let us use now catalyst. So if I use the catalyst, the activation energy will decrease, so let this be the new diagram. Now the activation energy decreases by 10, so I can say that this value is 10 now, right. So now you need to find the activation energy for the backward reaction, means you need to find this value, that is, let me do it in some different color. You have to use this, calculate, you have to calculate this value, okay. So now you see this total was 50, 10 it decreased, so this is 40 and now this is 20, so 40 plus 20 is 60. So the correct answer here is option number A, very simple one. Coming to next question here, for the reaction PCl5 plus Cl2, the rate, okay, again we have from chemical kinetics, okay, question is from chemical kinetics and the topic here is rate law, a very easy question. So there is a reaction PCl5 giving you PCl3 plus Cl2, the rate and the rate constants are given, okay. So what is the rate here? So the rate is 1.02 into 10 to the power of minus 4 mole liter inverse second inverse, okay, and we have rate constant, the K value is 3.4 into 10 to the power of minus 5 second inverse, right. Now we need to calculate the molar concentration of PCl5 at that instant. So let us write like this, rate is equal to K into concentration of PCl5, okay. I have this value, I have this value, can we not calculate PCl5 value? Yes, definitely. So just substitute here, 1.02 into 10 to the power of minus 4 is equal to 3.4 into 10 to the power of minus 5 into concentration of PCl5, okay. So now if you calculate this one, okay, now if you calculate this one, you'll get the value like this, PCl5 will be equal to 1.02 into 10 to the power of minus 4 by 3.4 into 10 to the power of minus 5, okay. So now let us substitute this, and once we calculate you will be getting 3 moles liter inverse, okay. So the correct answer for this question is option number B, okay. Now let us go to the next question, the 15th one. Which one of the following does not represent Arrhenius equation? Again the question is from chemical kinetics, okay, and this is again the topic here itself is Arrhenius equation. So we know the Arrhenius equation form is K is equal to A into e to the power of minus EA by RT, right. So you can see if you take log on both sides we'll get this term is already there, and if you take ln we'll get this term, but in no case this minus can become plus, right. So that is why this is the correct answer, this does not represent the correct form of Arrhenius equation. This is very simple question. Let us see the next question here, question number 16, identify the incorrect statement. So yes, this one is from the chapter that is surface chemistry, okay, but this chapter is again your deleted portion, so deleted topic, so need not very much. So values of colligative properties of colloidal solution are of small order compared to the values of true solution. Yes, that's the correct statement. Tyndall effect is observed only when the diameter of the dispersed particles is not much smaller than the wavelength of incident light. This is also correct statement. Color of the colloidal solution depends on the wavelength of the light scattered. Brownian movement is due to the balanced bombardment. So if you have studied Brownian movement in your like junior classes, you might be knowing that it is a very random movement of particles, right? There is no balanced movement in Brownian movement. So that is why this is the incorrect statement. Okay. Let us go to the next question. So this is also from your surface chemistry chapter. For the coagulation of positively charged hydrated ferric oxide sol, the flocculating power of the ions is in the order. So flocculating power, if you want to calculate, it is proportional to the charge. Okay. So now if you see here, for the there is 1 3 minus charge, 1 2 minus charge, 1 minus and 4 minus. So more is the charge, more will be the power to coagulate. So that is why 4 minus, 3 minus, 2 minus, 1 minus. Correct answer is option number D. Again, this is from the deleted portion. Okay, deleted portion. Now let us go to the next question. Gold sol is not a. So again, this question is also from surface chemistry. Okay, deleted topic. So you need not study this chapter. Okay, do not worry why so many questions were asked. There was some like this year some questions were asked from the deleted topics, but later they were not evaluated. Okay, they were discarded. So you need not worry that, or need not get tense that okay, if I do not study, what will happen. So nothing like that. You can skip these deleted topics. So gold sol is not a macromolecular colloid. Okay, it is made up of small dispersed particles, so it is not a macromolecular colloid. Correct answer is option number A. Now coming to question number 19. So this is from your isolation, is extraction of elements, right? Metallurgy. So this topic is also deleted. So we'll discuss this in little brief. The incorrect statement about Hall-Héroult process is, so here in this oxidation state of oxygen changes in the overall reaction. Okay, so oxidation state of oxygen remains constant, it does not change. So that is the incorrect statement here. Okay, now coming to question number 20. Again, this is also from the same chapter, deleted portion. Okay, so roasting involves the heating in the absence of air, it is in the presence of air. So this is incorrect. We need to find the correct statement here. Calcination involves the heating of ore above its melting point, this is also incorrect. Smelting involves heating the ore with suitable reducing agent, this is wrong. Calcination of calcium carbonate is endothermic, yes, this is an endothermic process, heat is evolved. So the correct statement here is option number D. Now coming to question number 21. So again, this question is from your P block, right? Group 15. Again, deleted portion. NO2 gas is a, but still you can do this question if you have done practical experiments and you know the color of the gases, right? You can definitely solve this question. So NO2 is a brown gas, all of you might be knowing that, and if you add NO2, like if you mix NO2 gas with water, we get HNO2, nitrous acid, right? So this oxide is acidic in nature. So correct answer for this question is option number C, brown and acidic. Now coming to question number 22. Identify the incorrect statement from the following. Okay, so again this is about group 16. Okay, again deleted topic. Oxides of nitrogen in the atmosphere can cause depletion of ozone layer, yes, correct statement. You need to find the incorrect statement. Ozone absorbs the intense ultraviolet radiation, so this I think everyone will be knowing, general science things. Depletion of ozone layer is due to chlorofluoroalkanes, this is also correct statement. Ozone absorbs infrared radiation, this is incorrect because we know ozone absorbs UV radiations, right? So the correct answer for this question is option number D. We need to find the incorrect statement. Okay, now let us see the next question here. The correct decreasing order of boiling point of hydrogen halides. Okay, so now we have reached to group 17, but you might be knowing as we go down the group, the mass increases, van der Waals forces increases, and that is why the boiling point will increase. So what is the expected order here? So hydrogen iodide, then hydrogen bromide, then hydrogen chloride, then hydrogen fluoride, right? But now what happens is in hydrogen fluoride we can find intermolecular hydrogen bonding. Now due to this hydrogen bonding, what happens? The boiling point of HF increases even more than the HI. Okay, this was an exception. So what is the correct order here? HF, HI, HBr, HCl. Okay. Okay, now coming to the next question. The synthetically produced radioactive noble gas. So this is from your group 18. Okay. Synthetically produced radioactive noble gas by the collision of CF with Ca, this produces your oganation. Okay, correct answer is option number C. Again, this is from deleted topic. Now coming to 19th question. So that is from your D and F block. Okay. The transition element present with lanthanide metals in mic metal. So D block, lanthanoids. So this one is your iron, right? You know mic metal composition 5%. Very important question, this one. Okay. Now coming to next question. Match the following. Okay, so we have Zn2 plus. So if you know what is Zn2 plus configuration, Zn2 plus is D10 configuration. It has no unpaired electron, because of which it is colorless. So Zn2, so I can write it like this: 1, 2 and 3. Okay, so Zn2 plus is colorless. So 1 is 2. So we can eliminate these two options. Now copper 2 plus. Copper 2 plus, if you see the configuration of copper 2 plus is D9. There is one unpaired electron, so magnetic moment will be 1.73. So for 2 it will be 3. So for 2 it will be 3. So we can eliminate this one also. Correct answer will be option number B. Now nickel 2 plus configuration is D8. So that is also correct answer. Okay. Now coming to the next question here. Which of the following statements are related to lanthanide is incorrect? So again we have D and F block question. Okay, lanthanides are silvery white soft metals. Yes, this is the correct statement. We need to find the incorrect statement. Samarium shows +2 oxidation state. Yes, this is also correct. Ce+4 solution are widely used as oxidizing agent. This is also correct, because Ce+4 can undergo reduction. When it undergoes reduction, it will behave as a good oxidizing agent. Now color of lanthanide ion in the solution is due to DD transition, right? This is incorrect. It is due to FF transitions. Okay, so the correct answer for this question will be option number D. Now coming to the next question here. So we have reached now coordination chemistry. Okay, so this is coordination chemistry from Werner's theory. Okay, now let us discuss this question. On treating 100 ml of 0.1 aqueous solution of complex CrCl3.6H2O with excess of AgNO3, 2.86 gram of AgCl was obtained. So you know what is there? We have this one, CrCl3.6H2. This is a complex, but we currently do not know the formula of this one. How much is this one given? 100 ml. Okay, and 0.1 mole. Okay. Now, if this one is treated with excess of AgNO3, then what it will produce? AgCl. How much? 2.86 gram. Okay. So now what is happening? We have to find the formula of the complex. So now let us find the number of moles of this one. So you know number of moles formula is what? Molarity into volume. So if I want to calculate, molarity is equal to number of moles by volume. So if I want to calculate number of moles, it will be molarity into volume. So molarity is 100 ml and this one is 0.1. Volume is 100 ml, molarity is 0.1 m. So if I multiply this, I'll get 10 millimoles, right? And here if you see, this is 2.86 and molar mass of silver is 108, and this one we can take 35. So we'll get 143 for easy calculation. So I'll take number of moles given mass by molar mass, right? So I'll get 0.02, right? So now what we can do is we need to okay, so this is the total amount and this is the form. So now what we can do is we can divide these two ratio. Okay, so let us calculate this one, 0.02 by 10. Okay, 10 millimoles, so 10 into 10 to the power of minus 3. So I can write 0.02 into 10 to the power of 3 by 10. So I'll get 2 here. So that means what? Two chlorines must be outside in this compound, right? If 2 chlorines are outside, then you can see here, here there is no chlorine outside, here there is 1 chlorine outside, here there are 2 chlorines outside. So definitely correct answer is option number C. Now coming to question number 29 here, the complex compound CONH3(5) and CONH3(5) So there is an exchange of these two are called as. So these are your ionization isomers. Why? Because once you put this in water, we'll get this as 1 ion and Br minus as 1 ion. Here if you dissolve this one is at water, we'll get this as 1 ion and SO4 2 minus as 1 ion, right? So that is why these two are related as ionization isomers. Now coming to question number 30. Which of the following statements are true about COF6 3 minus ions? Okay. So the complex has octahedral geometry. Yes, if you see coordination number 6, it always has octahedral geometry. Coordination number of CO is 3. So coordination of actually cobalt forms how many linkages, like how many bonds with 6 fluorines, right? So coordination number should be 6. And oxidation state, if you calculate, should be +3, right? So this statement is incorrect. Complex is sp3d2 hybridization. Yes, because of fluorine is a weak field ligand. So yes, this statement is also correct. It is a high spin complex. Again, this is a weak field ligand, so we'll get high spin complex because outer d orbitals are used. So now which of the following statements are true? We have 1, 3 and 4. So correct answer for this question is option number C, that is 1, 3 and 4. Okay. So this was your first 30 questions for your KCET 2024 paper. So when you are preparing for KCET 2025, it is very essential that you see the previous year papers. So I want every one of you to solve these questions, and if you have any doubt in any question, please comment down, we'll definitely address it. Okay. And yes, thank you for watching, and please subscribe the channel for more updates, and stay tuned for the next part of the KCET 2024 chemistry solutions.